All right. In this section, we're going to take the ideas that we learned in section 4.1 and basically keep compounding those and learning more about them. So this idea of the going back, this opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. We're going to keep with this idea and we're going to apply it to some of the angles that we saw when we made the unit circle back also in our previous section 2.1. So we're going to look at really specific triangles in this section 2.2 to get started out with. So we've got our triangles, and the angles that we're going to be looking at are this 45, 30, and 60. So when I'm asked to find something for the 60-degree angle, so for instance at this one or these two, I'm going to be using that triangle that's got the theta, my angle being 60 degrees, so the one in green otherwise. And then when I'm asked for 30 degrees, I'm going to look for that middle triangle. And then for 45 would have been the first triangle. It's all right if you don't have these memorized yet, but you will, by the time we get for exam 1, know the opposite over adjacent, adjacent over hypotenuse, all the what we need to know for the sine, cosine, tangent, cosecant, all those trig functions. And again, what we went over, this stuff right here that we went over in section 4.1 with the right triangle. That's where I'm getting all this information from. All right, so let's dig into some of these triangles. So example 1, the sine of 45 degrees. So I'm going to use in this very first triangle, looking my angle theta down there is in the bottom left. So looking at that, 1 is the hypotenuse, and then they happen to both be the same number, but the opposite is the one not touching it, and the adjacent is the one touching. I'm going to go ahead and label all of these. So for the 30 degrees, opposite is not touching, adjacent means it is touching, and then we have the hypotenuse. Same thing for 60. Opposite, adjacent, hypotenuse. Now that number 1 is the hypotenuse in every single one of the triangles. That is because in our unit circle, which I know I keep talking about, so going back up here to this page, our unit circle, all of them are a radius of 1. Let's see, I think we've got a filled in unit circle somewhere in here at the end of this section. Here we go. So we can see all the way out is 1 unit. Every radius has 1 unit. And these angles that we're looking at, 30, 45, and 60, are all on the unit circle. So these are triangles we could also find on the unit circle. In fact, as we get through section 2.2, we're going to put these triangles on the unit circle. But for now, we're going to do with triangles in our picture because that's what we had in our previous section. All right, so sine of 45 degrees, the sine is the opposite over the hypotenuse. So with this triangle that I've got, the yellow one, the very first one, the opposite is square root of 2 over 2, and the hypotenuse is 1. Now, anytime we divide by 1, a lot of times, like I've told you, we're kind of lazy in math. We don't write 1. I'm just going to say that's the square root of 2 over 2. Just like if I had 4 over 1, we would write that as 4. So I've got my answer right here. I'm going to leave the you try it's for just a second. So I'm going to do the other ones, and then I'm going to let you guys do those you try it's in just a second. So I'm going to go down to example 3. So I'm on example 3 right here, the cosine of 30 degrees. So I'm going to that middle triangle, the one in blue right here. The cosine is the adjacent over the hypotenuse. So adjacent on this one is a square root of 3 over 2, and the hypotenuse is 1. So I'm just left with the square root of 3 over 2. Again, I'm going to have you do the use try it in just a second. I'm going to keep going doing the other examples that aren't you try it. So now I'm going to move down to example 7. I'm just going to kind of go down these rows. I'm into the green triangle, the very last one, the one on the right, because I'm with 60 degrees. The tangent is the opposite over the adjacent. So in this one, that would give me square root of 3 over 2 divided by 1/2. Now, well, we can reduce this down. They both the numerator and the denominator have a 2 in the denominator. That's going to give me the square root of 3 over 1, which just reduces the square root of 3. Let me show you why I can do that. So a little work on the side. We have in math what we call keep, change, flip when we divide fractions. So you keep the top part, you change to multiplication, and you flip the bottom. Keep, change, flip. Same number on bottom as top, they cancel out. So this is the reason why I can do that. You can always show this work, keep, change, flip, or you can come up here to the top, and these are both in the denominator, so you can kind of do a shortcut that way. Got another one that I'll go over in just a second. I'm going to leave the you try it's. So I'm going to look at example 6. That's going back to the triangle with the 45-degree angle, so the very first one. The tangent, again, is the opposite over adjacent. So in this case, the opposite square root of 2 over 2, and the adjacent square root of 2 over 2. Those are both nasty, but remember, if you have the same thing in the top and the bottom, they cancel and we're just left with 1. That's the same thing as having 3 over 3 is equal to 1. It's nastier than 3, but it is the same number. Square root of 2 over 2 is in the numerator. Square root of 2 over 2 is in the denominator. So they're going to cancel out, and I'm left just with 1. Let me do one more. Let me do that example 8. The tangent of 30 degrees. Middle triangle, the one I've got circled. Tangent, just like we've seen in a lot of these, is opposite over adjacent. So the opposite is 1/2. The adjacent is square root of 3 over 2. You saw that keep, change, flip means I can cancel out. I'm left with 1 over the square root of 3, and you can stop right there. Let me show you that keep, change, flip. So 1/2 divided by square root of 3 over 2. Keep, change, flip. A 2 on the top and the 2 on the bottom cancel, and I'm left with 1 over the square root of 3. You can leave your answer right there. My math lab's going to go one step further and rationalize the denominator, and going to get square root of 3 over 3. You can have that answer or 1 over the square root of 3. I am happy with either one. Stop, rewatch, write your notes down, do everything you need to, get all this in order, and then I want you to try the examples that I have left for you. So go ahead and make sure, rewatch, rewind, then pause the video and try example 2, 4, and 5. All right, coming back from the pause, and if you did not pause, then you should pause and try examples 2, 4, and 5. I'm just going to clean up a little bit so we have a little bit more space here to work 2, 4, and 5. But you can rewind if you need to go back and look at those. All right, example 2. You were supposed to do that one. That was the cosine is adjacent over hypotenuse. So looking at the 60-degree one, the one on the end, that triangle, I'm going to get the adjacent is 1/2 and the hypotenuse is 1. So I'm left with 1/2. Again, that 1 in the denominator, we just don't write that because we're lazy. Sine of the same triangle is opposite over hypotenuse. So I'm going to get square root of 3 over 2 divided by 1. Again, same way with the denominator, I'm left with the square root of 3 over 2. And then last one I wanted you guys to try, example 5 there, move into that middle triangle. A sine again is opposite over hypotenuse. So the opposite in this case is 1/2 and the hypotenuse is 1. So I am left with 1/2. Rewind, go back, make sure you have your notes, work these as many times as you need to.